class. Today I will share with you what is a process capability. Process capability is under course outcome 3, ability to develop the process capability in engineering applications. The learning outcome for today is you able to use the process capability to analyze your process in engineering field. Next is the scope for today. What are we going to talk about? Today, this video will cover concept of process capability and process variations, kind of the variation, and what is the concept, that means definition for the process capability. Then the next video I will cover how to calculate the process capability for a process and the process performance for a process. Both of this is using formula for that, so I have the calculation part in here, so I will cover in next video. Okay, what's the concept of the process capability? The purpose of the process capability is you, like a crystal ball, you're able to predict the futures. You're able to predict your futures, such as you can predict what is the test will be going on in next few weeks. So the crystal ball will tell you maybe the test will come out with QC2 problem. So this is the function of the crystal ball. Unfortunately, crystal ball is not around you, and the crystal ball cannot help you to predict the process. That means the process always, the performance of the process is difficult to predict with the crystal ball. Is not accurate. So when you process have many variables, the process always come out different quality. Is hard for you to predict the outcome. So in this chapter, the crystal ball will be equal to control chart. The control chart, the purpose of the control chart is like the crystal ball. You can predict the process capability. That means you can predict this process can produce a good lot, robust lot. That process cannot because of capability problem. So the control chart is fully utilized in this chapter. Please understand well what is a control chart in chapter 8 before you go deeply this chapter. Okay, thank you for that. Okay, what is a concept? Definition for process capability is in quality planning, it is to ensure that the process should be stable and capable to produce the part that can meet the customer requirements, specifications. The process capability is a concept that provides a quantified prediction. That means it gives you a numbers. The number can as a reference for you to predict your process whether can come out a good product or bad product. So have a number for you. It's a calculation part, right? It is the measurement of the variation on the product turned out by the process. That means the product is produced from the process. So the variation from the measurement can tell you, is it this process is good enough, is stable, is capable or not. So before I go deeply about the concept of the process capability, we have to learn about what is the process first. You have to understand what is the process stand for. Process is a combination of machine. So maybe you have the machine in your process, have the materials, have the label, and different environment in your operations in your operation field. So maybe your measurement got a problem. So all these variation is happen in process. So anything you put into the process and come out another product, that is called process. As you know that the process is influenced by many variations, such as input variations, raw material variations, component, equipment, tooling, operation method, uncontrollable issue, temperature, humidity is very uncontrollable. Controllable input, maybe you can set your machine in the desired setting, optimum setting, so that the machine always produce the same quality product. Flow rate, feed quantity. So all this is a variation for a process. You look at here, it's got so many variation here. So if have the different variation, different setting on this, sure the product come out have the different value. Different value is called variation. So this process capability purpose for this chapter is for you to narrow down all the variations so that you can produce a stable process to produce a quality goods. The key point here, as I discussed before, the key point, every process have the input, have this input 4M1E. The purpose for here is produce a stable process with the lesser variation on your product. That is what customer demand every time. This is the customer demand. LSL and USL is customer demand. This is customer demand. For example, I tell you I am your customer. I tell you I want this product produced in 2 cm here. 2 cm here. And the upper limit I can set until 2.3 cm. 2.0 until 2.3. So if your process can produce a product between 2.0 and 2.3, that means your process is very good. Your process is very stable and very capable. If you produce the product is something like this, or the product is belonging here. Here is considered defect because I cannot accept any product lower than 2.0 cm, then any product higher than 2.3 cm. So this is a defect. So that means your process cannot achieve my requirement. So your process is not capable. Understand? Then next, subtitle 2 is a process variation. Why we need to understand what is a variation? So many variations happen in your process, so you have to understand well where is the variation come from. Maybe first one, within the unit. One unit, let's say a ruler. You measure the thickness of the ruler in the different location will have the different reading. That is the variations. Second one, between the units, you have 2 or 3 rulers. You measure one same location between the 3 rulers. Among the 3 rulers also have the different readings. That also called variations. Next, time to time. If you measure a product in the morning, that means just come out from the process, such as furnace, that means the product still hot. You go to measure, maybe the measurement is different with the product after few hours cooling down because of the sinkage issue, because of the weightage issue. Okay. Then lastly is an instrument and a human error, measurement error. That means you use different measurement apparatus, equipments, and the skill of the operator also. So that is a measurement error. So in the previous slide, I have stated that the variation is come from 4M1E. So 4M1E equipments, maybe using different equipments, tool-wear problem, machine vibration problem. So all this one is the variations come from. Okay, all the variation we can conclude it into summary into 2 types of the causes. First one, we can say that the variation is a chance causes. It's a natural causes. Then the second one is an assignable causes. It's a special causes. So what is the difference between these two causes? Natural causes is unavoidable. It will happen naturally, such as to where longer you use the tool to operate the products, to produce the product, the tool will wear. This is a natural cause, so you cannot avoid this. It will happen naturally, but you will notice that if it is a natural causes from 4M and 1E, your control chart will be stable like that. Although this is the highest, but still within your control limit. This is a natural causes. How about assignable causes? Okay, before I go for assignable causes, what is the natural causes? Example for natural causes: vibration of your machine, temperature and humidity a bit different, normal wear, maybe machine setting is shifting a bit, then maybe the computer response time delay, human response to the traffic light system, maybe different response. So this is a natural causes. Then how to reduce these natural causes? First, maybe you can change the process technology by you can do some maintenance to your machines that is can solve these natural causes, or you can introduce Poka-yoke. What is Poka-yoke? To reduce the human error. This is Poka-yoke. This is Poka-yoke design. Poka-yoke design, that means you purposely design in the different shape for assembly purpose. That means the operator cannot assembly if they are not in the correct order. So this can reduce the human errors, careless from the humans. Then this one, sure, if you did notice clearly, you will assemble wrongly also. This is a Poka-yoke. Okay, understand? Then we go to the assignable causes. If your process have the assignable causes, that means your process is not stable enough. Something wrong somewhere. You have to solve it now. You cannot delay it, because always produce a product is not fulfill the requirement for the customer. Such as incorrect setting. Suddenly you put wrong setting there. Then operator is not follow instruction. Defects of your raw material, broken part, wrong procedure, poor production design, no maintenance at all, lack understanding, poor worker is too tired. So although you get the control chart is something like this, it's still under control, only one outlier here, but the trend is getting higher and higher. So you have to do something to prevent more assignable causes happen in your process. Assignable causes will be like that. Maybe today we'll produce, achieve, tomorrow suddenly, oh, we're good, achieve product. Then suddenly too many defects. Then you can predict your future. How is it? If it's a common causes, so the process is very stable, you can predict the quality from the process. So this is today's lessons. What is the process variations? Process variation can be divided into two. One from the natural causes, another one from the assignable causes.